All right. So the difference between this one and the one we worked a while ago is these have different powers for the roots, and so therefore we're not looking at square root anymore. We're looking at the 6th root and the 4th root. Thank you, lamp. I love lamp. And so we're looking at the 6th root and the 4th root of these, and so that also plays a role into what we can combine, not just that the radicans are the same. We can only combine the same kind of roots, and so therefore we got to simplify them, and what I know so far is that this one is already simplified as low as it can go. So 4 times the 6th root of 3 has got to stay. Bring down my sign. Okay, and so I'm going to do the 4th root of 32. Okay? And so now it doesn't help me to ask the question, what perfect squares exist inside of 32? It can, but you're not taking the square root of anything anymore, so I'm not eliminating the square, I'm eliminating thing times 4. And so it's better to go ahead and just factor them out, factor tree kind of concept. And so, since I know 32 is even, I know 2 is a part of it. 2 times what?
16.
Very good. Okay. We'll factor 16 as 2 times 2 or 4 times 4. Doesn't matter. I know the great thing about 4 is both of them are perfect squares. And so that's going to be 2. And this is 2 times 2 times 2 times 2. And so therefore I have it broken down to what we call the prime factorization. If I was prime factorization this would be 2 to the 1, 2, 3, 4, 5 power. That's the prime factorization of that. So, looking for 4s of things. And so here are 4s. And so 1 will come out. The other 3 are eliminated. And I'm left with that one, correct? And so I have on the outside 4 to the 4th root of 2. Everybody okay so far? We're going to bring down our subtraction. And so now we've got to take the 6th root of 192. Once again, finding just the perfect squares is not going to help us. And so, what do we know? Oh, this is 6th root. What do we know about the number 192? What factors give you 192? I hope to God we're paying attention. This is for you. Never forget that.
96.
Okay, 2 times what?
96.
Good. So what I want you to say is that 2, since it's even, it's 2 times 96. Okay, and as you can see, we're going to be breaking this down quite a bit. Maybe we'll see some perfect squares show up so we can factor it out. 2 times what?
48. And then 24.
Okay, and this is going to break down to 2 times 2 and 2 times 24. All right, I know there's some perfect squares in 24. Okay. But you got 2 times 12. Two times 6. And then your last one, hopefully. Just be careful you never lose any of your 2's as you're bringing them down. So what I would encourage you to do as you're looking at this is multiply this product out and make sure you get your original one. So if I go 2 times 2 times 2 times 2 times 2 times 2 times 3, make sure that that equals 192. At least check yourself. You're not having to do that many of them that you can't check to see if you factored it right. Because now what we're looking for is 6 things in a row, and there's 1, 2, 3, 4, 5, 6. So here's 6 of them right here. 1 will come out. All those will be eliminated, and we're left with 3. And so I have 6, the 6th root of 3. Okay? We've already factored this, right? And so 192 factors out as 2 square roots of 3 with the 6th root. Do y'all agree with that, or do I need to do it again? Everybody good? Don't have to do it again? All right, and so if I bring that out, there's going to be a 2 that comes out, which is going to make that 4. The 3 is going to stay underneath. And so what we are going to work with here in just a little bit is going to be 4 to the 6th root of 3 and 4 All right, everybody okay with what I'm trying to combo right here? All right, and so I know that that one minus that one, that's going to happen. Do y'all agree? And so what I'm left with is 4 to the 4th root of 2 and 6 to the times the 6th root of 3. Okay. A lot of paying attention to details that you